So we'll be seeing about Titanic spaceship project in this video series. So this is the application. This is the application. We will be having some categorical and numerical values. So through that, we will be predicting the result and then giving it in the UI. Also, we have also integrated the MLOps pipeline. If you give slash train here, so you can see that the training done successfully. That is in backend, right from data ingestion to base model creation, and then to model training and then deployment. It will be taken care, and then the train model will be given to the user. So let's see how to deploy it. Let's see how to create it from the scratch hereafter. This is a MLOps project. So we will be setting up MLOps pipeline from data ingestion to prediction stage, and then it will be deployed in AWS using Flask and PyTorch serve. We will be also using DVC pipeline and then CICD setup, and then the DB is Cassandra DB. So these are the skill sets you will be gaining from this project. Uh, the base data set which we are going to use is Titanic spaceship data set. I have took a simple data set so that it will be good. It will be easy for everyone to understand and explore. So this is the data set which I have used. So let's code. Okay. First, I will be downloading the data set. Oh, something. Okay. So I've logged in. So now let's download the data set for the project. Also, let's create a repository in GitHub. Just have a readme and then git ignore. Okay. Let's download it here. Sorry, let's clone it here. Okay, good. So I'm using I'm using WSL Windows uh, uh, like I'm using Ubuntu for Windows. So that's why I'm getting a screen like this, and I'm working. I'm able to. I would be able to execute Linux commands in Windows. Like if you are using Windows, use appropriate commands for it. So this is the train dataset which we are having. Dataset which we are having. So for both training and testing, we'll be using the same dataset. Because our end goal is to make a MLOps project rather than to uh, uh, achieve a good accuracy. So the project will be more the this video will be more concentrated on achieving uh, how good the MLOps pipeline is, how we are how to set up the pipeline, everything. So that is the end goal of this project. So initially, let's have a template. So I'll create a file called template.py. So what is the use of this is you can for any project that you are working in MLOps, like you can have this template so that there will be a definite structure for it, and there is no need for you to repeat it for every project. So logging is one of the most important function in every project. So we have imported the logger. Then we can give a project name. I'm giving Titanic spaceship. So then we can import the list of files that we need. So first file is for GitHub workflow. So this is where we will be setting up the CICD pipelines. Uh, then this is the structure of the pipeline which we are having. There will be components in utils. We will be writing whatever. If you want to download something, download script, know the size of the file. Those things we will be writing. Then in config, we'll be giving the configurations. In pipeline, we will be writing pipelines for data ingestion, then base model creation, model training, and model evaluation. Entity, it will be having a definite structure which the config should be. So and then constants. In constants, mostly whatever the constant file which we are going to import. For example, configs and parameters will be the constants, and some other things if it comes up, you can add it there. Yeah. And then okay. So now we can set up Conda environment. So I went to install Anaconda and then I came again now. So I've installed Anaconda now. So we can set up the Conda environment. Sure. Okay. Now let's go inside Conda environment. So now I'm going to execute the template.py project. Sorry, file. So if you see the everything is created. So now we can install the requirements for this project. So these are the requirements. We are going to use Torch framework. For data pre-processing and post-processing, we'll be using Pandas. Then DVC for the data version control. We'll be using Python notebooks for research purpose or exploration. NumPy, Matplotlib we'll be using. I don't think we'll be using Matplotlib and Seaborn in this project, but I've just imported it from another project, so it's okay. Uh, then then this Flask we'll be using. Then PyML for the PyML for extracting the YAML file. Cassandra driver for connecting with Cassandra DB. Scikit-learn. This is also for data preprocess. We'll be creating pickle files using Scikit-learn, and then tensor board for visualization, experiment tracking, torch serve for serving, and then torch model archiver and torch workflow archiver also for serving only torch serve. ONX, we will be converting the Torch model to ONX, and then we will be using it with Torch Serve. And then now let's go to setup.py. So in setup.py, we can set the version for this project, and then how for example, how do you create a Python package? So it is in that way. So it will give you a setup for the project. Yeah. So first we are so these are repo name, author username, src repo, and author email, source repo, and okay. So and then setup tools. So here we are reading the README. and then setting up the long description for the project. So what the dataset does is, the spaceship Titanic dataset does is, they have given some informations on passenger information, like their age, which planet they are from, and then like the description of the project is they are going in a spaceship. So the spaceship has crashed, and then some persons are I think I'm not aware of the exact story, but some persons were transmitted to the next dimension. So based on the details we have to predict whether they are transported or not. So that is the objective of this project. So the story, like you can read the story. Uh, yeah, this is the story. Yeah, and then yeah. Now let's dive into the project. So starting, we can create a notebook, and then first we can pre-process. We can check how to pre-process the data, and then come up with things. Okay. Okay. So before starting to analyze the data set, let's install the required uh, packages first. You have to get inside the Fonda environment. After that, you have to install the packages. Okay, I missed one thing. So we have to add -e here. Yeah, because we are it enables the setup of the So the packages have been installed. So now let's create a basic pre-processed data now. First, let's import pandas. Sorry, my extensions are being installed here. So after so now pandas has been installed. Now um, now let's create the data. Sorry, read the data. I don't know about the sound. I think the sound is from notebook. So uh, let's see what are the unique how many unique planets are there in the home planet. So if you see, there are some Indian values, some and other things are Europa, Earth, and Mars. So we will be working on removing the missing values. So before that, I'll be disabling the sound. 1 minute. I'll check it. Okay, now I fixed it, and then I restarted the kernel. So now now let's see in destination column how many unique destinations are there. Because we are seeing this because those are the categorical terms which are to be analyzed, and then other things are mostly numerical. uh, Data destination unique. So if you see, there are also missing values here. There are three other destinations. Uh, we'll be discarding the cabin future, and then the name future here, and then we'll be using the rest of the data still here for training, and then uh, we'll be using the transported as our prediction value. Why? We are discarding passenger ID also because it's of no value. It's like a serial number. Cabin, and then the name. You can add cabin also, but it involves more amount of pre-processing steps. So I have discarded it as of now. So after discarding it, if you see that, so if you see that the non-null values, if you see that everything is changing, like only I think the transported column will be having non-null values, exact non-null values, because it's a prediction value. So, like I think that is the total amount of entries. If you see here the total amount of entries and transporter will match, we need to fill all these columns somehow to make sure that our data set is devoid of null values. So let's see how to fill the missing values now. So first is categorical values. So to deal with categorical values, for example, the home planet, and then cryo sleep, and then the destination, and then the VIP. So these are mostly categorical values. We'll be taking the mode, that is the which is the most repeated one, and then we'll be filling those values with the null values. Sorry, with the null values with those values. And then now we can fill the numerical values, that is the uh, yeah, age, room service amount, food court amount, shopping mall, spa, and then beer deck amount. So these things we can fill. So these things we can take the median of those values, and then we can fill it. So I'm using a extension, that is tab 9 AI. So that's why you're seeing the autofill. Uh, that's why you're seeing the autofill lines. Now, if we try to print the missing values from data dot is in name dot some. So there are zero missing values. So if you see the data dot head, so we can give the name to first column as serial number, and then we can save it. Index.name, because it will be helpful for you in saving it in DB, and then for extracting it, else you need to add some arguments in pandas to process that. So we have got that here as CSV. So now let's go to DB and then upload it. So if you see here, I have created the DB already, spaceship DB. So if you even if you want to create, you can create. I'll tell you the procedure how to create it. You have to go to create database. Then you can give a name, spaceship DB2 I'm giving, and then you have to give any one service. I used to give Google Cloud there, and then you can give anything there, and then create database. So after creating it, uh, like after that you have to load. It will take some time. So after that you have to load the data. From top right corner there'll be a in top right corner there'll be an icon load data. So you need to load it here. Select the file, load the sample data set like here. Yeah, so that will be the process. It will take some time to initialize the database. That's why I already created it. Uh, so now after creating, you have to go. You can go to connect, and then you have to download the bundle, get bundle. And then you can go here and then click download the token. So once you download it, yeah, we have already installed the Cassandra driver there, so we can set up the connections. So I will copy both of the things and then paste it here. So now uh, let's go to data ingestion stage. That is the first step. So in the data ingestion stage, initially we can for initiating that we can create a notebook data ingestion dot ipynb. So first let's check the path where it is. So it's in research folder, but we have to move it to the previous folder. So that is that spaceship Titanic MLOps project folder. We have to move it there. Because all our code base will be based on that folder only. So whatever code we are writing, we will be writing based on that folder. So at first, we are creating a config. So the data ingestion config. So in the data ingestion config, we are going to specify the root directory where it is, and then I will show you the config file like which we are going to create. So first we have to create the config file. Yeah. So the root directory is artifacts data ingestion. uh, Artifacts will be created. Artifacts data ingestion. This is the place where we'll be storing the data set, and then the data file, local data file. This is the name of the data set, and then cloud config zip file and authentication token, which we have downloaded now. So that will enable us to connect with the cloud DB, which is the Cassandra DB. Okay. Then let's import the constants. Okay. So first we have to now we have to create the common files. So the common files are common files will be from utils folder. We have to write it there. We can create a common common.py. So under this, first we can import the necessary things which we needed. Then we are creating a definition for reading the YML files. We'll be having two YML files. One is config file, and then another one is the params.yml file. And then we'll be creating directories also. So for the root directory, whatever we are creating, so that for those things, the like this people and other and other utils which we need will be created here. So now if we import, okay, logger. So we have to create the logger also for, after this. So logging is the first thing I should have written. I should have written and showed you, but sorry. So I will show you how the logging is done. So if you see, we are importing the packages. Then here logging str. So this is the format which we are going to log. Then log directory, and then the running logs are stored here. So after that, the root directory will be formed, and then running logs.log will be stored in it. We'll be getting the logs inside it. Then the logging configuration, and then this is the logger which will be importing it everywhere. So now we are going to import it. Okay. Okay, it has got imported. Then now we are going to write the data ingestion class. So for that we have to import necessary things. Cassandra D. This is the main class where which is going to interact with the Cloud DB and then download the file. First, we are getting the config. After that, we are downloading the file. We are writing the class to download the file. So initially, the secure bundle config. So that path is here, which it is being fetched from the config.yml file, and then the authentication token that is being read with the client ID and client secret. The cluster connection is made, and the query is ran. So this query I have limited it to 10 because we'll be making many calls to it, and then the download there is a particular limit for downloading and then uploading data. So that's why I limited it 10. While we are doing actual thing, I'll remove these things. Yeah. So if you want, initially we can keep because I've written most of the things. So there won't be much errors. But in case if you are working on debugging something, you can keep the limit to 10, and then so you can execute the cell. Next, we are writing the configuration manager. So these data will be stored in the config manager file. So before writing config manager, we have to set the constants. So in constants, if you go to constants, we have to read two files. One is params file and another one is config.yml file. So those things are written here. Params file we can update it. I know the features what is it is going to come. We are going to have 14 features. So I have given it 14 because we will be doing one hot encoding. So it becomes 14 features. Okay. I need to restart the kernel again. Logger is not defined. Sorry, I should have imported these things. Yeah. So it has been downloaded. So it has become failed because the failed connecting because a file already exists. So it because we executed it twice. If you want, I will show it again. Yeah. Now it is showing correctly. It has downloaded it, and the information it is showing here, the columns information. And then now we are going to we are going to we are going to copy it to the proper files. So there is a pattern there is a pattern for this. So in which we will be updating most of the most of the class for most of the things we will be using this pattern only. First, we will be updating the entity. So in entity, we will be creating a config entity, config entity.py, and then we will be updating it here, and then data ingestion. So for this data ingestion, we will be updating in components init folder. So init file. So this is the place where we will be inserting this one, components init. Okay, there is no other error, I think so. So after this, configuration manager. So configuration manager we will be keeping this under configuration.py file. And then the configuration manager, we have to import and do the processing. So this one will be under, this one will be done on the pipeline. So you can go to pipeline and then create a file, stage 01 data ingestion.py. We can import necessary things which we need. After that, we can import the stage name. So after writing the stage name, we can copy this class data ingestion train pipeline. Yeah. So after this, we'll be writing the we'll be writing the if name equal to main perform. So we can call this and verify if it's correctly, if it's able to correctly import. Then we can add it to the main folder also. Main. Just to call main.py. Okay, it's already there. So file is already there. So it skips the downloading part and then stage ingestion is completed. So now let's go to next one. So after data ingestion, we are going to data preparing base model. So now before going inside in next stage, we can push what we have done to the Git. Okay. So these artifacts. So these artifacts and data folder, we can add it to. We can add it to Git ignore. So now if we say the Git status, now it's now we can add everything. For some security reasons, no. like we can deactivate the DB later. After this video, we are going to deactivate the DB, so we can add the secure spaceship DB token also to Git, and then we can deactivate it later. But make sure that it is not you are hibernating the you are for every 2 days. If you are not using a DB for 2 days, then the Cassandra Cloud Cassandra DB will be hibernated. You have to reactivate it again. So for me, there was no problem. For me, it's not a problem. If there's a problem for you, you have to find some way to use the token uh, yeah, differently rather than pushing it to Git. Yeah, commit, add initial files, add stage, add data ingestion files. Okay, push origin main. Okay, I pushed it here. I pushed it to the Git. So now we can go to next stage. So the next stage is preparing a baseline model. So in the baseline model preparation, same way, first we are going to the directory which we needed. And then we are importing the necessary config. Before this, we have to update the config.yml file also. So in config.yml file, we have to update necessary things. Yeah, preparing base model. Under that, root directory we have to give. So this is the root directory artifacts prepare base model. In that base model path, this is the file name in which the base model path will be saved. Okay, so this is the base model.config. So here root directory and then base model path from parameters we'll be fetching the learning rate and features. So configuration manager. So like earlier, we are importing the reading the YAML file. While transferring this into a .py file, we will be removing these things because we'll be adding only this function to the class, because just to utilize it inside the notebook, I've used this function. So yeah. So here, if you see, we'll be creating the root directories first, and then reading the base model config, and then it will be going to the configuration manager, initializing to the configuration manager. So this is our base model. There are 4 layers from 32 hidden. First, it will be getting the input size. input sizes, input size and filters, uh, and then it is yeah, and then it is going from. So here we are importing the base model. So if it's enough if we give the input size and output size, and then these are the hidden layers. So I wrote it to so that it can be simple. For each and every layer there should be a ReLU, and then at last it is a specific mode because it is going to predict whether it's a true or false only. So I gave it a sigma activation function. So after this, we are writing things to say our base model and the get base model functions. Okay, and is not defined. So first we are getting the config, and from the config we are preparing a base model, and then we are getting the base model. So here the input size will be 14 because that is the future size, and the output size will be 1 because we are going to predict it's true or false only. So that's why. And then yeah, if you see in the directory artifacts, prepare base model.pt is being saved there. Now let's transfer it to the files. This will be going to entity. So after entity, this will be going to the configuration manager config. We have to import base model config from entity. Okay, so after this, we are going to write the model. So prepare this we can create it inside the components. And then our base model class also we can write it inside the components. after this, so this one we have to write inside the pipeline. So if we go inside the pipeline, stage 02, prepare base model.py. So inside this, we have to write it. We have to write the stage name, prepare base model, and then we have to write the class name and initialize it, and then definition main function. So in the main function, we can import this. Yeah. So after importing this, we can go here and then main, and then we can, like how we did for data ingestion, you can write those information here. So now we can go to main. You can just copy and paste this. Stage name also is similar. Okay. So I'm just commenting it out because it will require in the DB again and again. Okay. So yeah. So if we now see, we can run Python main.py. Cannot import. Okay, I should have wrote it differently. Sorry. Titan stage 02 prepare base model import. Yeah. Okay, it's creating it successfully. So after this, we are going to the third stage. So in third stage, it is preparing the callbacks. So in the callbacks, we will be writing callbacks to save a checkpoint, and then we'll be also using it to using it for tensor board. So both of them we'll be using. So let's see how to write that. Okay, like let's change the directory like previous notebooks, and then we can import the configs. So prepare callback configs. So yeah, before that we are update the config file. So if you see the config file, prepare callback configs. Yeah. First we are giving the root directory, and then tensor board log directory, artifacts, prepare callback, tensor board directory, then checkpoint model file path directory. So all these things we are setting it. And then where we are in prepare callbacks. Okay, so there then we are importing read OEML and create directories file. For that we have to execute this. So it's get prepare config. So in this we are creating the directories and then preparing callbacks. So in the callbacks, we are giving tensor board and checkpoint, not a checkpoint saving methodology here. Um, so for that, we are uh, so prepare a callback config. So here we are first creating the directories, and then we are getting the path of tensor board directory and checkpoint saving directory. That is in the configuration manager. After that, we are importing necessary packages in Torch. There is you have to import the tensor board like this. Torch utils a tensor board summary writer. And then this is saving the best model class. So it will be fetching the like the input will be for the class will be the file path where it is to be saved, and best validation accuracy is initiated with 0 value. So as the best validation accuracy is normally fluke, or like whenever the best validation accuracy is breached, if it's if the current validation accuracy is exceeding the best validation accuracy, best validation accuracy will be stored as the current validation accuracy, and then it will be saved to the checkpoint folder. And then prepare callback class. So in this class, we are initiating the config, then creating the TensorBoard callbacks, and then writing the summary, giving it to the summary writer in a specified format, and then creating the callbacks as a return type. Like in return, whenever this function is called, we retain the callbacks class which are being created as the objects which are being created. So after that, yeah. So now here, so if you see here, this is the classes which have been created there will be returned as a classbacks list. So this will be utilized by the training during the training. The configuration manager. Okay, it's done. So now we'll be copying this to respective files. This will be copied to entity. This will be copied to configuration. Okay, I think it's clear of errors. So after that, we'll be copying uh, two components. This also to the components. Okay, it's being copied, it's being imported. After this, we have to go to the, there is, after this, the pipeline is not needed because we'll be integrating this with the training pipeline. So, as of now, let's push to the Git and then we can move forward. So now let's go to the next stage. So the next stage is model training stage. So we are went to the Space Titanic MLOps project folder. So from this folder, then we are importing the training config. So training config is this. So before doing that, we are also adding the necessary uh, parameters in the config.yml file. This is the root directory, and then checkpoint model file path directory, then train model, encoder pickle, and then ONX model path. So these are the things we have to add up there. Yeah, the callbacks we are there because we will be using it in the training pipeline also. Next, we have to import the necessary packages. Suppose sklearn one encoder, we'll be using it to encode the categorical values. Configuration manager. So in the configuration manager, we'll be importing like callbacks first we'll be writing, and then we'll be writing the training config now. So next, it is save best model and then prepare callback classes. So this one we have already wrote it from the prepare callbacks notebook. So we are just using those things. So we are writing a custom dataset class so that the order is maintained. For the train loader, we need a dataset class. So that's why we are using a dataset class. And then we are writing the training class. So training class. So this is the training class. First, we'll be getting the base model, and then we are initializing it with the binary cross entropy loss with 0.01 learning rate, and then we can discard these things. We are we are importing we are taking the data transported, that is the transported column alone, and then we are converting into int type because it consists of only true and false columns. So we are converting that. Then we are dropping the serial number and transported from X, and then saving it into X for X. So this is the training. This is the data we'll be using for training and testing, and then one hot encoder. So in this one hot encoder, we are in like one hot encoder is used to encode the home planet and destination columns alone. This cryo sleep and VAP columns are two and like they consist of Boolean values. So we can convert it to int float or int vector and use that. There is no need to one hot encoder. Mm. And then we are saving this encoder in a pickle file because we'll be using it during the post processing, during the pre-processing of in our inference script. We will be using it. And then we are converting it. We are encoding it and then converting to arrays, and then in the data frame we are importing it inside the data frame, and then concatenating it with the original X, and then yeah. here home planet and destination alone is dropped because once we concatenate it, we'll be having the concatenate the multi-column encoded values. We'll be having the one not encoded features of these two columns. So we are dropping these two columns and concatenating it. Next, we are converting into tensors because PyTorch to feed it to the PyTorch we need tensors, and then we are training it. So here, this is saving the model to our destination path. It will be copying from the checkpoints path and that to the desired path which we need. And then this is the training pipeline. So in the training pipeline, it will be fetching the input and labels from the data loader. So I have like here the train and test split is made. So we are set to 0.20 and the random set to 21, so that it's the randomness is maintained while evaluating also. So and then here the loss function is inputs are fed to the model, and then the loss function is being calculated and then back propagated. Then after that, this is the evaluation pipeline. So for each and every epoch, the evaluation is also being done, and then the checkpoint save is being done. Then the once entire thing is done, from the checkpoint directory, which is the best saved model, it is copied to the desired path. So here the configs are being got. From the configs, callbacks are being got. And then callbacks, this will be storing the callbacks classes or class objects, which in turn is being fed to the training pipeline. So now we can trigger the training. Okay, encoder label has no attribute config box. These things I should have deleted it. Sorry, I didn't delete it. These things are not needed. During my experimentation, I used those things. Here at all, I have deleted it, I think. Encoder train data is only there. Okay. So if you see here, we have got around 76.72 accuracy. So this is the best validation accuracy till we have got, and it's been saved with our callback function. So after this, we'll be transferring this to the required files. So after this, we will be importing training. For the training component, we'll be importing this one, training.py. I can comment this out. I didn't use this. Log checked away. Okay, so we are done with this, and then we have to write the pipeline. Stage 03 training.py. So here we have to import the necessary imports, and then we have to give the stage name, and then we have to write the class name, model training pipeline, definition, name, set, then we will be writing the username name one. Yeah, so after this we can transfer it to, you can save this, you can transfer it to main and then test it. Yeah, okay, now we are good to go and test it. Yeah, it's training properly, and we have on the and the model and pickle is saved. Okay. So next is the evaluation stage. So after this, we'll be going to model evaluation part. So the evaluation config, we'll be fetching from the training config itself some things, and then for evaluation config, there is no separate thing. We have to write in config.yml. And then we have to import the necessary packages, and then the config manager. So this is the config manager, the base model of path, and the part of the model that is being trained, and then the training data for validation, and then the encoder path, which we encoded the values, and then the ONX model path, then the parameter feature, and then parameter batch size are being used here. So once evaluation is done, we will be converting it to the ONX ONX1 ONX pack ONX model. We'll be doing that. So let's see how to do that. So like training said, the custom data set is there. Then this is the evaluation class. So first we are getting the base model. Then this is the validation generator. Similar to the training, we are also doing the necessary pre-processing steps. These things can be remitted. Yeah. So we are neglecting the X-train and Y-train and taking only the X-test and Y-test for evaluation. Here we are converting the ONX torch to ONX script. We are using this API torch.onf export. So if you give the dummy dummy random variables, it will be giving us it will be converting us the torch model into ONX model, and it will be providing it to us. Once the conversion is done, it will be checking the outputs of both the model. If it matches, it will be using exporter model has been tested with ONX runtime, and the results looks good. So this is output we'll be getting. So evaluation pipeline is similar to that. Similar first validation generator. Then we are loading the test loader. Then the input labels and output and the input and the output labels. Input is passed to the model, and then the output of the model is being tested with the labels. So after we get the losses, and then it will be sorry, after we get the accuracy, it will be saved under test accuracy, and then conversion to 1x will be done, and then for serving the torch So for that, it will be copied. So for the torch serve, we have to create a folder torch serve here. So it should be created in the root directory. Torch serve. Okay. By mistake, I created a in templates. Torch serve. I will give it as a file folder name. So this will be creating files only. Torch serve. So in torch serve, we need some models folder, and then utils folder. Okay. So once it's been created, we can run it. Yeah. Validation config is got, and then it is passed by evaluation class, and then base model is got. From the base model, evaluation is done, and the scores is being saved as a JSON, like loss and accuracy will be saved. So if you see exported model has been tested with ONS and result codes looks good. We have got a test accuracy of 77.34. Then if you go inside the models and see space shift.1 is greater, encoder train data typically is greater here. The same way under training, also we have space shift.1 and training data encoder.pickle. So it's good. Let's copy this. This should be copied to configuration, evaluation config, and then now we need to copy the components. So the components evaluation.py. Yeah. So we have to import necessary things. Entity dot con config, import, evaluation config, and Titanic spaceship dot details dot common, import, save JSON. I think everything is imported now. Path is there. Okay. From pathlet, I think. From pathlet, import path. Okay. Now we are good to go. So pipeline. So now we have to write the pipeline. Stage 04 evaluation.py. We have to import necessary things and then the stage name. So after this, we have to get the class name, and from in the class name we have to now import the main. We have to give the main function. So in the main function, we can import whatever we wrote here. Okay. So after this, so let's write this. Next, we are going to set main. So in the main, we'll be using, yeah. So we can check now whether it's working or not. Okay, I didn't write import the stage name here for training. And then I will import stage name for the evaluation. Okay, now I need to import from Titanic spaceship pipeline stage 4 evaluation, import evaluation pipeline. So if we test the evaluation pipeline, yeah, it's good. So evaluation pipeline is being done. Now we have to go for predict. So prediction is there now. So let's look at the prediction method. Same way, we are going to change the directory. Then we are importing the necessary packages. So first we will check how to predict it using Torch, and then because we have already seen how the ONX is predicting. If you want to check the ONX predicting, you can go to evaluation pipeline, and then you can use this code. This is the code which is being used to infer the ONX output. So this code also you can use, this torch code also you can use. I wanted to show two variations of it, so I'm using torch here, and then in deployment we'll be using ONX there. So first we can check for this one. Sometimes the output won't be matching because the accuracy for this is only 77%. I took some random values that it is matching now. So for you, if you see here, so this data is being converted into it is converted in the data frame, then uh, the boolean is converted into float, and then the encoder pickle is being read, and then from encoder pickle it is being transferred to array, and then that array is again transferred to data frame, and then combined with the one of the encoded features of home parameter and destination. So after that, the model is being loaded, then checkpoint is also being loaded, and then the state it inside the model, the state it is being loaded and the features are being fed, and then we can see the result on the it's not defined. Okay. So if you see it is false, the if you see the original one, so this is the original one. This is the original one. The transported column is false for this. So the output lies below 0 for it. And then if you see, if you want another one, different data set. So this is on a different data. So if you run this and then run this, it gives true. The value we have set 0.3 as threshold because it gives a good accuracy. So I've set 0.3 as threshold for the test set. It gives good accuracy. So if you want to know the original feature of it, so this is the original one. It is true. The transport type, the transporter column is true, and what we are getting is also true. Okay, so we'll be writing the prediction pipeline now. So what happens is in this prediction pipeline, we are transferring to Torch. Okay, so Torch serve. So this prediction pipeline is being done by Torch serve. So we'll be writing those things there. So before that, we'll commit it what we have done till now. Okay. So prediction, I'll tell you now how to write the prediction pipeline. So what happens is we'll be calling the API only, Torch Serve API. So from there we'll be getting the data. So from there we'll be getting the data, and then we'll be returning it to the main Flask app. So first we can see how to set up the Flask app.py. Okay, app.py. So app.py first we have to import the necessary functions. So one thing we have to write is in components decode data. So the decode data helps you to decode the imported the whatever data that is being sent from the HTML. It will help you to decode it and then transfer it to the model. So that is transferred as feature to the Torch API. So that one we have to write it. So that code, yeah. So that code we can write it in components. What it does is it receives the data, then so this is a decode data function. So return type is return type is a dict. So it will be doing the necessary pre-processings which we need to be sent to the torch function. Save the notebook and then close it. And then in app.py, we are first importing the logger for the app.py. So the basic logging will be happening in the basic log will be happening in the terminal, but we are also doing it inside the file also flash logs.log. Client tab. So here we are importing the prediction pipeline. So it's an optional one, like you can also write the prediction pipeline here itself, but we are wrote it there, and then so and then this is home page. Homepage from where index.html is fetched, and then this is stop server. So if you want to stop a server, you can use this function to stop a server. Like inside the Docker, it will be hard. Like either you have to get the use LSOF and then get the process that is running a port ID and then kill it, or else you can also use this function. Then this is train function. So I will be telling you later about this after this segment. This is predict function. So in this predict function, first this request.json, this will be getting it. This will be got while the predict button is clicked. We'll be getting that data from predict HTML page, and then it will be decoded, and from decoded it will be sent to predict function, and then it will be returned. So this predict function we are going to write it now. So we have reduced almost most of the packages that we are going to import. So this is the class which we are using. Uh, yeah. So uh, So this futures, so this futures will be posted to 8080 port, and then we'll be getting the predictions from there, and then it will be returned. 8080 port is the place where we are hosting the torch serve function. Okay, so I will tell you now about the DVC. So DVC means data version control. So in data version control, we can it helps us to manage the there is no need of doing a repeated work. For example, in main.py, every stage, when we run main.py, each and every stage will be running, even if if it has already run. For example, this data ingestion stage, it was downloading whenever I run to test if I want to only train a model and then not to download it from DB. If I use a main.py Python file, it will be doing all the stages one after another. But in DBC, it maintains a version control system, which will have a checksum of your data. So using that checksum, it knows that the data has not changed from previous values, and then it will be skipping those stages. So this is dvc.yml file. I will first in data ingestion. This is the command which is being which is used to run. So this command, as you know, we have wrote if name main statement there inside each file. So this is where it will be used. So those files, and then the output of data ingestion stages, data spaceship.csv file, and then this is then prepare base model. So in prepare base model, we are running the Python file, and then the outputs are produced in a prepare base model. This is training. So if you want, we can add this also. Prepare base model, base model.pt. Yeah. So this is for training. So the outputs are model.pt and encoder train data.pickle. After that, evaluation stage. Evaluation stage. The output is spaceship.1x, and then encoder train data.pickle. So these are the outputs of M. Now if we run dvc unit, so the config is being created here, git ignore, and then some files are being created here. Now if I run dvc repro, so everything will be initiated. So I can comment this out now, because I'm not going to use dvc. I'm not going to use main.py character. dvc repro. So this is the command I'm going to use. So at first time it will be connecting, running everything. At first time it will be running everything. Oh, it is not able to produce spaceship.1xc. So if you see the stages are skipped, and then yeah, only evaluation stage is being run. The stage that have failed before. So it has been done, and then now now if you see its status, okay. So after this, we have to add the CICD pipeline. So GitHub CICD. Inside the workflows, you have to go inside GitHub workflows main.oaml. So in main.oaml, now we can add the GitHub workflow. So I will paste it. So whenever the commits are given to the main branch, it will be triggering the workflow. And if you commit only to readme.md, it will not trigger the workflow. And then continuous integration. So continuous integration is done, and then continuous delivery, and then here EC2 login is done. From EC2 login, the Docker is being pushed here to the ECR repo. Sorry, this is ECR. ECR login is done and it pushed to ECR repo. And then again, here with the credentials of AWS credentials, it is being there's ECR, ECR is checked in. ECR, Amazon ECR is being logged in. And then we are pulling from the ECR, and then from the ECR we are creating the container, pulling the image from the ECR and then creating the container. So the container, after the container is created, we will be using it. So I have enabled three ports. Yeah, three ports: 8080, 8081, and 8085. Okay, let's see how to do it. Now we are going to connect with the AWS and then create necessary things to set up our in Docker image, and then CI/CD pipelines, and then deploy our application. So that is the one we are going to do now. So I have written every step in the README for this. So if you see the README, so first we'll be creating the IAM user, then we'll be going to, this is optional one, and then we'll be installing, creating Docker in the EC2. So creating, installing Docker in the EC2, then with in GitHub Actions, we'll be hosting the, we'll be creating a new self-hosted runner, and then we'll be entering the secrets, and then pushing to the CI/CD pipeline. The CI/CD pipeline will be triggered. Okay, so I'll go step by step in accordance with this. Okay, first we'll be creating the IAM user. So first, we are creating IAM user with policies. These two policies we will be creating. We have to go to users, create user, and create under name spaceship, attach policies. So under policies, search for this Amazon EC2 container registry full access. So and then another one service Amazon EC2 full access. So these both are checked, and then now we can create the user. So after this, you have to click on the spaceship, your username. Then you have to go to security credentials page, and then you can create the access key. Here you can click command line interface, and then I understand about this should be checked, and then no need to fill anything here. Yeah, now you can download the .csv file. Okay, we have downloaded the access keys. So after this, we will be creating an ECR repo. You have to go to get started. It should be a private repo. Here also you can give spaceship, and then create repository. Okay, so it is being created. Now, now we can go to EC2. Launch instance, we have to click it. You can give a name, spaceship, Titanic, Ubuntu. You have to check it, and then here we can click xlarge, t2.xlarge, and then it's an optional one. You can, if you want, you can create a key pair. As of now, it is not like I'm using the previously used key pair spaceship 2. If you want, I'll show you. Like we are not going to use it here. Spaceship 3, create key pair. You can connect using putty to using to the terminal of EC2 like that. It will be useful. We have to allow to both of these things, and then we can take 32 GB of storage. Launch instance. Okay, so it is getting initialized. Now, if we go to connect, we can connect to EC2 and then install the Docker first. I have given the steps to install the Docker. Install Docker. We are first updating it and then upgrading it. and give OK to it. It's not a problem. And then we are getting the Docker script. Yeah. So now if you type Docker version, yeah, we are able to get it. Now we can go to our GitHub, github.com. Okay, I have not logged in this browser. So you have to go to a repository which to which you have pushed it. So this is the repository which I have pushed my codes. So here in settings you have to go in settings, actions, then actions runner. You have to click new self-hosted runner. You can click Linux, and then we have to execute these commands in our EC2. For this question, you can give enter. Here you have to give self-hosted name, and enter, and then enter. Yeah. Now I think we are executing the last command. Yeah. And .sh. Okay. Yeah. Now it's connected to GitHub and it's listening for the jobs. And then if you see refresh the runners page, you can see the self-hosted there. And then now we have to give the secrets. So actions. So we can create new repository secret. Access key ID. So AWS access key ID. If we go to downloads. So in downloads, we'll be having it. So I wanted to show it to you also. So that's why, okay, yeah, access key ID. So this is the access key ID which we downloaded from IAM user while creating the IAM user. So with this one, you have to paste it here, and then secret access key. So this one, secret access key here. You can put that here as secret, and then new repository secret. After that, region, AWS region. For me, it is US East 1. So if you go to the top right corner, you would be able to see it in your AWS account. So if you see here, US East 1 for me, I'm using North Virginia. So US East 1, that is. And then I have to add the secret. After this, AWS ECRA login URL. So this one you have to take the URL which is used for ECR, which you have with which you have created ECR. So if you go to ECR, here there is a URL. So this is the URL you have to use. You can there is no need to include the spaceship till .com. You have to include it. After that, you have to, after this, there is another one, single thing, ECR repository name. ECR repository name, we have given it a spaceship. So this is nothing but this is this repository name, spaceship. Spaceship. Okay, we have added it. So now I'll be committing it. I'll be committing the CICD pipeline, git status, git tag, git commit, again, add main.yml, sorry, add CICD, update, readme, git push, origin 9. So push to GitHub. If we go to the code here, okay, it is being running. You can see that the CICD pipeline is running. Actions. Continuous integration has been run. Continuous delivery is being running. So it will take some time. I will come back. So if you see here, model is being deployed. The CICD pipeline is we have got it success. So after that, if we go to the EC2 instance, so if you can see that EC2 it has succeeded. So now we can go to AWS. Sorry, EC2. EC2. And then we can open the instance to configure to change the security groups, to add a security group. So in security group, we have to go there and then we have to click edit inbound roles. So here we have to add a port. We can add a port 8085. So that is where our Flask is deployed. We have to select 0.0.00/0 and then you have to click save rules. If you click save rules, then you can go to security group. Sorry, you can go to the instance here. Where is instance? So instance. So here you can. This is the IP address where it is being deployed. So if you go here, type 8085. You are able to get that. So we can give any value here, like 65, 100.0, 100, 0, 100.0, 0. So predict. So it is given its result. So this is how the project works. Yeah. So this is the so we have also integrated the MLOps pipeline. That is whenever you call /train, it will be calling in turn. It will be calling DVC repro. So as you have seen earlier, DVC repro right from what it does is right from scratch. Like it will fetch the data from DB, and then it will create the base model, train it, evaluate it, and then give the result as training done successfully. So the code for this API is being written here. app.py, so train route. So this is the place where we are calling DVC repro. So here this is why it is training done successfully. So and then now let's see how to remove this instance, because it will be costing you more. So I'll tell you how to remove this instance. So you can cancel the job here, and then you can go here, go to instances, and then instance state, terminate the instance, terminate, and then you have to go to ECR. Here you can delete it. Then you can go to IAM user. So here, yeah, you can click this spaceship and then delete it. Okay. Now we are good to go. So thank you guys. Let's meet in